December 15th, 1944, 8:15 in the evening. Briefing room, Luftwaffe Base Cologne 1. Hauptmann Klaus Neumann couldn't suppress a chuckle as he studied the latest American anti-aircraft casualty reports with his fellow Staffelkapitans. The numbers were pathetic. American gunners firing thousands of shells to down a single German aircraft. The Americans spray bullets like children with garden hoses, Neumann told his pilots, tapping the intelligence summary with obvious amusement. Their gunners panic, fire wildly, waste ammunition. Tomorrow's mission should be routine. Their flak couldn't hit a barn if they were standing inside it. His wingman, Lieutenant Hans Weber, laughed. At least the British can aim. These Americans just close their eyes and pray to their dollar bills. The briefing room erupted in laughter. After 4 years of war, these veteran pilots had seen every type of anti-aircraft fire imaginable. Soviet flak was dense but poorly coordinated. British flak was accurate but predictable. American flak was simply wasteful, spectacular displays that consumed enormous quantities of ammunition while achieving laughably poor results. What none of them knew was that everything they believed about American anti-aircraft capabilities was about to become lethally obsolete. December 16th, 1944, 5:45 in the morning. 12,000 feet above Normandy, Belgium. Hauptmann Klaus Neumann adjusted his oxygen mask, still smirking at yesterday's briefing jokes about American marksmanship. As Staffelkapitän of 7/JG-27, he was leading 18 fighters in support of Operation Wacht am Rhein, Hitler's desperate Ardennes offensive. Below them, American P-47 Thunderbolts were providing close air support to ground forces, standard engagement parameters. Neumann had done this hundreds of times since 1940. His veteran pilots knew the drill: hit fast, climb away before the American gunners could even orient their weapons properly. What happened next would prove that the Americans hadn't just learned to aim, they had invented shells that aimed themselves. The first explosion erupted 50 meters to Neumann's left. No aircraft visible in that quadrant, no visible shell trajectory. Then another, directly ahead, close enough to rock his fighter with the blast wave. Then a dozen more, bursting simultaneously around his formation with impossible precision, as if invisible gunners were firing from the sky itself. In less than 10 seconds, 7 Messerschmitts simply ceased to exist, torn apart by shells that had exploded exactly where they needed to explode, without hitting anything first. Neumann dove frantically, his radio crackling with panic-stricken voices. Flak! Impossible flak! But there were no black puffs of smoke, no shell trajectories, no muzzle flashes from the ground, just perfect, devastating explosions that seemed to know exactly where German aircraft would be. What Hauptmann Neumann had encountered was America's most closely guarded secret of World War II, the VT proximity fuse, a revolutionary technology that would transform air warfare overnight and represent the greatest single advance in anti-aircraft effectiveness since the invention of radar. Within months, this magic shell would make large formation flying suicidal for the Luftwaffe and accelerate Germany's air defeat more than any other single weapon. The mathematics of destruction were already written in electromagnetic waves. Each shell contained a miniature radar transmitter that could detect aircraft at precisely the right distance and detonate with devastating effect. No direct hit required, no complex timing calculations, just automatic, scientific annihilation of anything that flew within its detection envelope. This is the story of how American scientific superiority achieved what conventional weapons could not. The systematic elimination of German air power through technology so advanced that enemy pilots thought they were witnessing magic. The shells that seemed to explode by themselves would prove that the war was being fought between 2 different centuries. The genesis of the proximity fuse began in August 1940, as German bombers darkened British skies during the Battle of Britain. D-Day. Dr. Merle Tuve, director of the Applied Physics Laboratory at Johns Hopkins University, received an urgent request from the National Defense Research Committee. They needed a solution to the fundamental problem of anti-aircraft fire: how to make shells explode at exactly the right moment to destroy fast-moving aircraft. Traditional anti-aircraft shells relied on time fuses, complex mechanical devices that had to be precisely calculated before firing. Gunners estimated aircraft speed, altitude, and direction, then set the fuse timer accordingly. The process required perfect calculations under combat stress, against targets moving at hundreds of miles per hour. Success rates were dismal. During the London Blitz, British anti-aircraft guns fired 20,000 shells for every German aircraft destroyed. Tuve's team proposed something revolutionary: a fuse that could detect its target and detonate automatically at the optimal distance. The concept was theoretically sound but practically impossible. with 1940s technology. They needed to miniaturize a complete radar system into a shell that would survive the shock of being fired from a cannon, withstand G-forces that would destroy any normal electronic equipment, and function reliably in all weather conditions. The technical challenges seemed insurmountable. The fuse had to be rugged enough to survive 20,000 G acceleration during firing, sensitive enough to detect aircraft at 70 feet, reliable enough to never malfunction, small enough to fit in a 5-inch shell, and cheap enough to mass-produce by the millions. Most experts considered it impossible, but American industrial ingenuity proved unstoppable. By December 1941, the first working prototypes were undergoing testing at the Dahlgren Naval Proving Ground in Virginia. The early models were crude, unreliable, and expensive. Each fuse cost more than an entire conventional artillery shell, but they worked. In test after test, shells equipped with VT fuses achieved hit rates impossible with conventional ammunition. The breakthrough came from miniaturization techniques that wouldn't be duplicated anywhere else in the world for decades. American electronics manufacturers, led by companies like RCA and Sylvania, developed vacuum tubes smaller than a thumb, circuits that could function after massive shock, and antennas that doubled as structural elements. Each fuse was essentially a complete radar system compressed into a space the size of a coffee cup. Security around the project exceeded even the Manhattan Project in some respects. The fuse was designated variable time, or VT, to disguise its true nature. Scientists were forbidden from discussing their work with family members. Factory workers manufacturing components had no idea what they were building. Even naval gunners initially believed they were using improved time fuses. The first operational use came in January 1943 in the Pacific, where the U.S. Navy deployed VT fuses against Japanese aircraft attacking American ships. The results were immediate and devastating. Ships that had previously required hundreds of rounds to down a single aircraft were destroying attackers with half a dozen shells, but the full impact remained hidden because naval engagements were isolated, and the technology's existence was America's most closely guarded secret. German intelligence had no idea what they were facing. Luftwaffe pilots reported strange new American anti-aircraft patterns, shells that seemed to explode at exactly the right moment, defensive fire that was unnaturally accurate, aircraft losses that couldn't be explained by conventional flak. These reports were largely dismissed as pilot error or exaggerated claims. Oberst Adolf Galland, general of fighters for the Luftwaffe, received increasingly disturbing reports throughout 1943. American flak has become uncannily accurate, wrote Major Johann Steinhoff from the Mediterranean Theater. Our formations are taking losses from anti-aircraft fire at rates we've never experienced. The shells seem to know exactly where we are. What the Germans didn't understand was that they were witnessing the application of American scientific research that dwarfed anything in the Reich. The VT fuse program employed over 1,000 scientists and engineers, compared to fewer than 100 working on all German proximity fuse projects combined. American industry was producing 100,000 VT fuses monthly by mid-1943, while German attempts at similar technology remained in the laboratory stage. The technical specifications revealed the gulf between American and German capabilities. Each VT fuse contained a complete Doppler radar system operating at 180 MHz. The miniaturized vacuum tubes, smaller than a child's finger, were manufactured to tolerances measured in thousandths of an inch. The antenna system could detect aircraft-sized targets at ranges up to 75 yards and trigger detonation within microseconds. By comparison, German anti-aircraft forces were still relying primarily on visual estimation and mechanical time fuses developed before the war. The most advanced German radar-guided flak systems required massive ground installations and could engage only single targets. American ships were carrying dozens of guns, each firing shells with individual radar systems more sophisticated than anything in the German inventory. The real shock for German forces came during the preparations for D-Day, as Allied naval bombardment demonstrated VT fuse effectiveness on a massive scale. Admiral Theodor Cranky, commanding German naval forces in the West, reported to Naval High Command in May 1944, enemy naval gunfire has achieved accuracy levels that defy explanation. Single salvos are destroying multiple aircraft. Our pilots report shells exploding at aircraft altitude with no visible impact points. The mystery deepened as more German pilots encountered the invisible death. If you're finding this historical analysis fascinating, make sure to subscribe and hit the notification bell. We have dozens more untold stories of technological warfare that changed history. Back to our story of how American science revolutionized air combat. The first major test of VT fuses against massed Luftwaffe formations came during Operation Overlord. On June 6, 1944, German fighters attempting to reach the invasion beaches encountered something unprecedented, a wall of automatically detonating shells that made formation flying suicidal. Hauptmann Josef Priller, one of only 2 German pilots to reach the beaches that morning, later described the experience. The flak was like nothing we had ever seen, shells exploding at exactly our altitude, no matter what evasive action we took. My wingman simply disappeared in a burst that occurred 50 meters from any aircraft. I saw his fighter torn apart by an explosion that happened in empty air. Allied ships offshore were equipped with thousands of guns firing VT Fuse shells. The heavy cruiser USS Augusta alone carried 12 8-inch guns and 12 5-inch guns, all capable of firing proximity-fused ammunition. During the first week of the invasion, Allied naval forces fired over 50,000 VT Fuse shells at German aircraft, achieving kill rates that were statistically impossible with conventional ammunition. The psychological impact on German pilots was immediate and profound. Lieutenant Hans Müller of JG-2 recorded in his diary, "How do we fight an enemy whose shells can think? They explode exactly when they should. Every time. It's not flak anymore. It's a death ray from science fiction. Our formations are being cut apart by invisible swords." German technical intelligence desperately tried to understand the phenomenon. Oberingenieur Wilhelm Runge, attached to Luftwaffe Technical Intelligence, examined shell fragments recovered from crash sites. His November 1944 report to the Air Ministry revealed German confusion. The enemy shells contain electronic components of unknown purpose, miniaturized radio equipment beyond our current manufacturing capability, function unknown, but correlation with aircraft destruction is undeniable. What Runge had discovered were fragments of America's most advanced electronics manufacturing, representing industrial capabilities that Germany couldn't match. Each VT fuse contained components that pushed the boundaries of 1940s technology: vacuum tubes with walls thinner than paper, circuits assembled with precision tooling, antennas calculated using electromagnetic theory that German engineers barely understood. The scientific foundation of the VT fuse demonstrated American superiority in multiple fields simultaneously. Radio frequency engineering, miniature electronics, mass production techniques, quality control systems, and metallurgy had all advanced beyond German capabilities. The fuse represented not just a single invention but systematic technological dominance across entire industries. By September 1944, the deployment of VT fuses had expanded to land-based anti-aircraft guns throughout the European theater. American and British forces were installing proximity-fused weapons at every critical target. The psychological effect on Luftwaffe pilots was devastating. Formation flying, the foundation of German fighter tactics since 1939, had become a death trap. Major Günther Rau, one of Germany's highest-scoring aces with 275 victories, encountered VT fuses during a bomber interception mission over Schweinfurt in October 1944. His post-war testimony captured the hopelessness. "We approached the bomber formation at 25,000 feet. The moment we came within range, the sky erupted. Not flak bursts. Explosions that happened exactly where aircraft were flying. 6 fighters destroyed in 10 seconds. No evasive maneuvers possible. It was scientific murder. Even mathematics of destruction were undeniable. Conventional anti-aircraft fire achieved hit rates of approximately 0.5% against high-speed aircraft. VT-fused ammunition achieved hit rates exceeding 7%, a 14-fold improvement that made defensive positions virtually impregnable. A single American heavy cruiser could defend itself more effectively than an entire German flak regiment. German attempts to counter the proximity fuse revealed the technological gap. The Reich's most advanced electronics research, conducted at facilities like the Deutsche Forschungsanstalt für Luftfahrt, had produced experimental proximity devices that weighed over 20 pounds and worked under laboratory conditions only. American fuses weighed 5 ounces and functioned reliably in combat. Dr. Herbert Wagner, leading German guided weapons research, examined captured VT fuse components in December 1944. His assessment was devastating. The Americans have achieved miniaturization we considered impossible. Their vacuum tubes are smaller than our experimental models, yet more reliable. Their manufacturing precision exceeds our laboratory prototypes. We are not fighting the same war. The impact extended beyond individual engagements. By late 1944, the mere threat of VT-fused anti-aircraft fire was shaping German tactical decisions. Luftwaffe formations avoided areas known to have proximity-fused weapons. Attack profiles changed to minimize exposure time. Close air support became virtually impossible in sectors defended by VT fuses. General der Flieger Adolf Galland, in his final report as General of Fighters, acknowledged the revolutionary impact. The enemy's new anti-aircraft ammunition has made our traditional formation tactics obsolete. Large formations are no longer viable. Individual aircraft can sometimes penetrate, but coordinated attacks have become impossible. We are fighting with 1940 tactics against 1950 technology. The industrial scale of VT fuse production demonstrated American manufacturing supremacy. By early 1945, American factories were producing over 400,000 proximity fuses monthly. The primary manufacturing facilities, RCA in Camden, Sylvania in Boston, and Eastman Kodak in Rochester, had been retooled from consumer electronics to precision weapons manufacturing in less than 18 months. Each production line represented technological capabilities that Germany couldn't replicate. The vacuum tube manufacturing alone required precision machinery that didn't exist in German industry. The glass-to-metal seals demanded materials science that German researchers hadn't mastered. The assembly processes required quality control systems that exceeded German peacetime standards. Meanwhile, German industry was collapsing under Allied bombing. The precision manufacturing required for proximity fuse development needed stable power supplies, skilled technicians, and access to rare materials. By 1944, German electronics plants were operating with slave labor in underground facilities. Quality control was non-existent. Innovation had stopped. The contrast between German desperation and American abundance was stark. While German engineers struggled to develop basic proximity devices in bombed-out laboratories, American scientists were already working on improved versions. The Mark 32 VT fuse, introduced in early 1945, was smaller, more reliable, and cost half as much to produce as the original models. Oberst Hajo Hermann, commander of Germany's ramming squadrons, witnessed firsthand how VT fuses had changed air warfare. His Sturmgruppe pilots, flying armored Focke-Wulf 190s, specifically designed to ram American bombers, found their missions impossible. We could approach the bomber formations, but the moment we entered range, proximity shells destroyed us. No ramming was possible. The shells exploded exactly where our aircraft were flying. The Christmas 1944 offensive, Operation Bodenplatte, demonstrated the complete failure of German air power against VT fuse defenses. The Luftwaffe's last major effort involved over 900 fighters attacking Allied airfields. Of these, 271 aircraft were lost, with proximity-fused anti-aircraft fire accounting for nearly 30% of German losses. The attack achieved tactical surprise but strategic failure. Hauptmann Klaus Neumann, the same pilot who had encountered proximity fuses over Malmedy, survived Bodenplatte only to record the systematic destruction of his squadron. We lost 8 aircraft to the magic shells, perfect explosions at exactly the right altitude, no direct hits required. They destroyed us with science we couldn't understand, using weapons we couldn't build. By January 1945, captured German documents revealed the psychological impact of VT fuses on Luftwaffe morale. Unit diaries described shell shock among pilots who had never been directly hit but had witnessed the methodical destruction of their formations. Medical officers reported stress casualties from proximity neurosis, pilots who became physically ill when ordered to fly against VT fuse positions. The technology gap had become a chasm. American electronics manufacturing was producing components that German research institutes considered theoretically impossible. The miniaturization, reliability, and mass production of VT fuses represented industrial capabilities that belonged to a different era of technological development. Dr. Wernher von Braun, captured at the end of the war, examined American VT fuses during his interrogation. His assessment revealed the magnitude of German technological lag. These devices contain manufacturing precision that exceeds our rocket guidance systems. The Americans have achieved in mass production what we cannot accomplish in hand-built prototypes. The electronic components are 15 years ahead of German development. The final statistics of VT fuse effectiveness defied German comprehension. In the Pacific Theater, ships equipped with proximity-fused weapons achieved aircraft kill rates of 85%, compared to 15% with conventional ammunition. In Europe, ground-based VT fuses increased anti-aircraft effectiveness by 600%. The technological force multiplier had revolutionized defensive warfare. The scale of American technological superiority was staggering. If you want to see more incredible stories of how superior technology changed the course of World War II, subscribe now. We're constantly uncovering these hidden technical battles that decided history. Now let's see how German leadership finally comprehended what they were facing. Hermann Göring's first detailed briefing on VT fuses came in February 1945, just 3 months before Germany's surrender. The report, delivered by Oberst Edgar Peterson from Luftwaffe Technical Intelligence, contained shocking revelations about American scientific capabilities. Goering's initial reaction was denial. Impossible. No army deploys such advanced weapons in such quantities, but the evidence was overwhelming. Peterson presented shell fragments containing electronic components that German industry couldn't manufacture, combat reports describing impossible accuracy rates, and intercepts of American technical communications, revealing production numbers that exceeded German wildest estimates. The Americans were firing more proximity-fused shells in a single month than Germany could produce conventional shells. The broader implications were devastating for German strategic planning. If America could miniaturize radar systems into artillery shells, what other technological surprises were coming? The proximity fuse represented systematic scientific superiority that extended far beyond individual weapons. It revealed an entire industrial civilization operating decades ahead of German capabilities. German scientists attempting reverse engineering of captured VT fuses discovered the depth of their technological disadvantage. The vacuum tubes alone required manufacturing techniques that didn't exist in German industry, but precision tooling, quality control systems, and material science represented accumulated advantages that couldn't be overcome by individual breakthroughs. Oberingenieur Hans Henkel, leading the German proximity fuse research effort, submitted his final report in March 1945. American proximity fuses represent technological achievement impossible to duplicate with current German industrial capability. The electronics miniaturization exceeds our laboratory research by years. Mass production at reported scales would require complete reconstruction of German electronics industry. The human cost of technological inferiority was measured in thousands of German aircrew. Luftwaffe pilot losses to proximity-fused anti-aircraft fire exceeded losses to enemy fighters during the final months of the war. Experienced pilots, irreplaceable after 5 years of combat, were being systematically eliminated by weapons they couldn't counter with any tactical innovation. Lieutenant Werner Hoffmann, one of the last German pilot trainees, flew exactly one combat mission before the war ended. His encounter with VT fuses over Berlin in April 1945 lasted less than 5 minutes. We approached the Allied bomber formation at dawn. The moment we entered range, our squadron simply ceased to exist. Explosions everywhere, perfectly timed. I bailed out immediately and watched 12 fighters destroyed by shells that exploded in empty air. The surrender of Germany in May 1945 brought Allied investigators into German research facilities, where they discovered the complete failure of German proximity fuse development. The most advanced German prototypes weighed 20 times more than American production models and achieved reliability rates below 50%. German electronics manufacturing was literally decades behind American capabilities. Theodor von Karman, leading the Allied scientific intelligence mission, reported German proximity fuse research never progressed beyond experimental laboratory devices. Their electronics manufacturing lacks precision machinery, quality control systems, and material science necessary for miniaturization. American VT fuses represent industrial capabilities that Germany never possessed. Post-war analysis revealed the systematic nature of American technological superiority. The VT fuse program had employed more scientists than Germany's entire electronics research establishment. American industry had invested more resources in proximity fuse development than Germany spent on all guided weapons research. The technological gap had been unbridgeable from the beginning. At the Nuremberg trials, Hermann Goering was confronted with evidence of American proximity fuse effectiveness. Presented with combat footage showing Luftwaffe formations being systematically destroyed by invisible explosions, his response captured German incomprehension. "We knew you had superior numbers. We didn't know you had superior science. Your shells contained radar systems more advanced than our ground installations." The VT fuse had achieved something unprecedented in military history: the practical elimination of large formation air attacks through technological superiority alone. No tactical innovation could counter proximity fuse defenses. No pilot training could overcome weapons that detected and destroyed automatically. Merle Tuve, the original architect of the proximity fuse program, reflected on the achievement in 1946. He created a weapon that could think faster than any pilot could react. German pilots were fighting 20th century wars with 19th century reflexes against 21st century technology. The outcome was predetermined by scientific method. The broader implications extended beyond World War II. The VT fuse represented the first automated weapons system, the beginning of electronic warfare, and the foundation of guided munitions that would dominate future conflicts. German pilots had been the unwitting test subjects for a technological revolution that would reshape all subsequent warfare. Today, and the National Museum of World War II in New Orleans, the display case contains a cutaway VT fuse alongside testimonials from German pilots who encountered them. The placard notes that this single weapon increased anti-aircraft effectiveness by 600% and contributed decisively to Allied air superiority. But the real story is told by a quote from an unnamed Luftwaffe pilot's diary. "We laughed when intelligence reported American shells that exploded by magic. We stopped laughing when our formation started disappearing. The shells didn't miss because they didn't need to hit. They just needed to get close, and they always got close." Fighting proximity fuses was like fighting mathematics itself, precise, predictable, and absolutely lethal. From December 1944, when Klaus Neumann first encountered shells that seemed to explode by themselves, to May 1945, when Germany surrendered partly from the inability to maintain air operations, the VT proximity fuse had revolutionized warfare through pure scientific superiority. German pilots had discovered they were fighting not just American industrial might, but American scientific progress that had advanced beyond their comprehension. The proximity fuse proved that wars between industrial powers would increasingly be decided not by courage or tactics, but by the depth of scientific research and the precision of technological manufacturing. German pilots had been brave, skilled, and experienced. None of it mattered against weapons that automated destruction itself, reducing human air combat to a mathematical equation with only one solution: American victory through technological supremacy